Hello guys, today we're going to continue from where we stopped on regression analysis. In our previous class we used the least square method to estimate the parameters of a regression equation. Today we're going to use a different method known as a matrix approach to estimate the parameters of a linear regression. So the question says, using the data below, obtain the regression line of y on x using matrix approach and predict the value of y when x is equals to 25. Here is the data. Okay, we have our x, which is the independent variable, and y, the dependent variable. So we're going to start solution. We first of all write down the regression equation. This is the equation connecting these two variables, where this beta naught is the intercept and this one, beta 1, is the slope. This epsilon r is the error term, which is assumed to follow normal distribution. Okay, in using matrix approach, the parameters beta cap is equals to what? X transpose X inverse. Okay, X transpose X inverse multiplied by X transpose Y. Okay, this is our X, this is the matrix X. This 1, 1, 1 here accounts for this intercept here in this equation, and this is the actual values of this X. Okay, this is our Y, the matrix Y, and the beta naught, and this is the parameters. Here ranges from beta naught to beta n depending on the number of independent variables involved. Okay, so but in this case we have only one dependent and one independent variable. So our beta naught, our beta, which is the parameters, is equals to, will give us only beta naught and beta 1. So what to do, the next step is to what? To get the transpose of x. This is our x. So we have to get the transpose of this x, and we get the transpose by interchanging this row. We turn this first row to first column. So we'll be interchanging these rows and the column to form the transpose of this particular matrix x. So if we perform the X transpose, now will give us X transpose will give us 1. This first row will turn to first column, 1 and 5, 8, 10, 16, 17, 23. This is the X transpose X, the matrix X transpose X. So from the formula we have our beta cap is equals to X transpose X inverse. So we first of all obtain X transpose X. Okay, and this is our X. This is equals to this is X transpose X. So we're going to multiply this X transpose by this X. And two matrices is said to be multiplied by each other. Like for instance, we have a matrix A and matrix B. And they say you should get A multiplied by B. For this multiplication to hold, the number of column in A must be equal to the number of rows in B. So if you apply this condition here, we have our A transpose. How many columns do we have here? We have 7 columns. And our X, we have 7 rows, which means that this multiplication is going to hold. Okay? So in performing this multiplication, this first row will be used to multiply this first column and sum them together. This first row will also be used to multiply this second column and also take the sum. Okay, let's perform it together. This will give us 1 times 1. 1 times 1 will give you 1. 1 times 1 will also give us 1. Plus 1. Okay. We also use this first row and multiply this second column. 1 times 3 will give us 3 plus 1 times 5 will give us 5. 1 times 8 plus equal to 8. 1 times 10 is equals to 10. 16 plus 17 plus 23. Okay, we are done with the first rule. So we're going to use this second rule and multiply this first column and take the sum. This will give us 3 times 1 will give us 3, plus 5 times 1 will give us 5, plus 8 plus 10 plus 16 plus 17 plus 23. Okay, we have to use this second row again and multiply this second column, which will give us 3 times 3 will give us 9, plus 5 times 5 will give us 25, plus 8 times 8 will give us 64, plus 10 times 10 will give us 100, plus 16 times 16 will give us 256, plus 17 times 17 will give us 289, plus 23 times 3 will give us 529. So if you take the sum, you have that our X transpose X is equals to 7. If you sum this, you have 82, 1272. Okay, this is the result we have after multiplying X transpose by X. So we have this matrix. If you see this, if you check this matrix now, you know that if you take the transpose of this matrix, it will also give you back this matrix. So that's why we call it a symmetric matrix. So a matrix is said to be symmetric if its transpose is equal to that particular matrix. Okay, the next step is to get the inverse of this matrix, which is X transpose X. Now, to get the inverse of S transpose X inverse is equals to adjoint of S transpose X all over what? The determinant of X transpose X. This is the formula for getting the inverse of a matrix. There are other methods like row echelon operation, but in this example we are going to be using this particular formula to obtain our inverse. Okay, so let's get the determinant of S transpose X first. The determinant of this, this is a 2 by 2 matrix. Okay, for you to get the determinant of this 2 by 2 matrix, you multiply this 7 by this and subtract it by this, multiply by this, which will give us the determinant of x transpose x is equals to 7 times 1272 minus 82 times 82, which will give us 7 times 1272 will give us 8904 minus 6724. So if you subtract 6724 from 8904, we have our determinant to be what? X transpose x to be 2180. So this is our determinant of this matrix. This matrix X transpose X is also called information matrix in response surface methodology. Okay, so the next step is to get what? The adjoint. But before we get the adjoint, first of all get the matrix of the cofactors. So for you to get, in matrix, this is how the sign goes. For example, we have a 2 by 2 matrix. So the sign equivalent to this will give us this is positive, negative, negative, positive. So we'll only be making use of these signs. Okay. For C11, this C represents what? The cofactors. C11, this C11 is called row 1, which is the matrix, the value that will be here. C1, row 1, column 1. So if you come to this matrix here, this is our C, the position of our C11. Okay. When you see the number that is opposite to this 7 is equal to what? 1272. Okay. You pick this and multiply it by what? This sign, which is positive. So we have our C11 to be plus 1272. Okay, the next step we get our C12, which is row 1, column 2. So our C12 is equals to, this is the position of our C12, which is row 1, column 2. So when you come here now, the number that is opposite to this 82 is what? Is also 82. And you multiply this 82 by this sign, which is negative, which will give us minus 82. Okay. Since the matrix is symmetric, so our C21, which is row 2, column 1, will also be what? Minus 82. And our C22, which is row 2, column 2, will give us this is the position of the C22. So the number that is opposite here is what? 7. You multiply by this sign, which is positive. We have plus 7. So you put them together in matrix form. You have C, which is the matrix of the cofactors, is now equals to our C11 is 1272 minus 82 and 7. This is the matrix of the cofactors. Okay, so the adjoint now is the transpose of this matrix C, and since the matrix is symmetric, so you don't need to take the transpose, because if you take the transpose, it will also give you the same matrix. So our adjoint now, is equals to adjoint of X transpose X is equals to 1272 minus 82 7. This is the adjoint of this matrix X transpose X. Now the inverse now will be the inverse which is given as S transpose X inverse is equals to adjoint of S transpose X all over the determinant of S transpose X. So our adjoint is this, which will give us a 1 over, our determinant is 2180 divided by adjoint, which is 171272 minus 82 minus 82 and 7. So this is the inverse of this matrix. Okay, so the next thing we need to do is to get our S transpose Y. So we're going to multiply S transpose by the matrix Y. This will give us our S transpose Y. This is our X. S transpose is equals to X transpose is equals to S transpose is equals to this matrix 1 3 5 this is our X. Our Y is equals to our Y is 6, 8, 9, 13, 24, 22, 30. This is our Y, our vector Y. So we're going to multiply X transpose by Y. So if you check these two matrices, it can be multiplied, the multiplication can hold because the number of columns here in X is equal to the number of rows in Y. So let's perform the multiplication. So we have 1 0 1 5 1 8 10 16 17 23 multiplied by this matrix, which is 6 8 9 0 24 22 30. So we've used this first row and multiply this column and take the sum. So this will give us 1 times 6 will give us 6 plus 1 times 8 will give us 8 plus 1 times 9 will give us 9 till 13 24. 1 times 22 will give us 22 plus 1 times 30 will give us 30. We now use this second row and multiply this column also and take the sum. So this will give us 3 times 6 will give us 18 plus 5 times 8 will give us 40 plus 8 times 9 will give us 72 plus 10 times 13 will give us 130 plus 16 times 24. 16 times 24 will give us 384 plus 17 times 22 will give us 374 plus 23 times 30 will give us 529 So if you take the sum, you have, if you take the sum of this, you have a matrix S transpose Y to be equal to, S transpose Y to be equal to 1, 1, 2, and then 1, 1, 2 and 1, 7, 0, 6. This is the matrix X transpose Y. Okay? So now that we have gotten our S transpose Y and also S transpose X inverse, so the formula says beta cap is equals to S transpose X inverse multiplied by X transpose Y. We have gotten the value of X transpose X inverse and also X transpose Y. So we're going to multiply the value that we have here with this to give us, let's perform it together. This is the value of our S transpose X inverse. So we have S transpose X inverse to be 1 over 2180 by 1272 minus 82 minus 82 7 multiplied by our S transpose Y, which is 112 and 1706. Okay, this is what we have: S transpose S inverse multiplied by S transpose Y. So we use this first rule and multiply this column and take the sum, and also use this and multiply this column and also take the sum. So we have, this is multiplying this one, all these things in this bracket. So 1272 all over 2180 multiplied by this will give us 65.35046 minus 82 times this divided by 2180 will give you 64.170642. Okay, now you also use this second rule and multiply this column. So if you do that, you have minus 4.21284 plus 5.477982. So if you take the sum, if you subtract, you have this to be equal to 1.17982 and 1.26514. This is what we have. So, and our beta naught, this implies that our beta cap is equals to what? Beta naught is equals to 1.17982. Okay, and our beta 1 cap is equals to 1.26514. Okay, so the regression equation now will be y is equals to 1.17982 plus 1.26514x. Okay, this is the regression equation that we have, the estimated regression equation. So let's put our y cap because it is an estimated regression equation. Okay, the second question says we should predict the value of y, which is the dependent variable, when our x is 25. Predict, the second question says predict y when x is equals to 25. So what you do is just to substitute the value of, to substitute 25, to just replace this s with that 25. So this will give us that our y cap is equals to 1.17982 plus 1.26514 multiplied by what? 25. This will give us y cap to be, if you do the multiplication and take the sum, you have y cap to be 32.80802. So this is the value of y when x is equals to 25 from this estimated regression line equation. Okay, thank you. So if you have any problem, any question, drop it in the comment section. So in our next class, we'll be looking at what? Correlation analysis. Okay.